everybody! So this video is going to go over some things about static methods, static variables, and some other random things about classes. And so the first thing I want to talk about is public and private access. So we've all learned about public and private access in terms of instance variables in a class. So for example, in the class to the right, if you have a circle class, it has an integer radius, integer x value, and y value, and these are all declared as private. They're declared as private because if you are going to access them from another class, we don't want to be able to directly modify those variables from that other class, because then when you have 100 classes, right, so say you're a software developer and you're making a ton of classes, it would be really hard to debug if radius was something that needed to be changed. You'd have to change the code in 100 classes. So we keep them private. But just to go over the difference between the two in terms of making objects, if radius had public access, so if you were trying to access the radius of some random circle C1, and it did have public access, then if we were in some other class, like main, right, the main class, we could just write system.out.println c1.radius. So c1.radius would give me access to the radius of circle 1. I couldn't just say system.out.println radius because whose radius are we printing? Are we printing circle 1, circle 2? I don't know. So you would have to specify which circle you're printing the radius of. Now, if this was declared as private, which it should be, then you would have to use a getRadius method in order to print the radius of circle 1. So private access is what you're going to see most often, and what you're going to see on the AP test for objects like circles. Also, if you're in the same class, so if you're in the same class as the circle class, then you could just print out radius without having to use a getRadius method or a C1 reference. So, knowing that, let's try the next question. So the next question says, consider the following class definition. We have a class called boolTest. It has an instance variable called 1. It's an integer. It's declared as private. Then in this class, we have a constructor, and that constructor takes an integer. It sets our 1 instance variable equal to new 1, which is the parameter. Then we have a get method for get1, and we have an isGreater method. And so what the isGreater method does is it returns true or false. It returns a Boolean, and it compares the current object, the current boolTest object, with another boolTest object. So you see this pretty often when you write .equals methods because you're comparing the two objects. So the first object is this one. It's the one that's currently attached to the class, and the other object is the parameter, boolTest other. So in this question it says the isGreater method is intended to return true if the value of 1 for the boolTest object is greater than the value of 1 for the boolTest parameter other, and false otherwise. So the following code segment has been proposed to replace the missing code. The first one is return 1 greater than other dot 1. And notice here that this code is going to be written in the same class as boolTest. So public boolean isGreater, this is where your missing code is going, right here. So would the first one work? Return 1 greater than other dot 1. 1, remember, is the instance variable that is tied to the class. Option 2 would be return 1 is greater than other dot get 1. So do we need other.getOne to get the value of 1 from the other object, the other bool test object? Or can we just call it using other.one? Or do both work? Or option 3 would be return get1 greater than other.one. So which of the following code segments would allow us to run the method as intended? So what do you think? So this one was 1, 2, and 3, and that's because we're in the same class. So just because one has private access, if you're in the same class, then you can just access it by saying other.one, and you can get the value of the bool test other. If you were not in the same class, if you were in main, then you would need to use the get1 method and only the get1 method to get the value of 1. All right, next we're going to talk about static methods. So we've already kind of talked about static methods throughout the year. So static methods are methods that do not need an object to call it. So for example, math.squareRoot is a static method because it's called using the class name and not the object reference. So if you're taking the square root of 20, you don't have to make a square root object or a math object before taking the square root of 20. You can just call it by saying math, which is capital M math, which is the name of the math class, dot square root. Same with math.random. All of these things, they are static methods because they do not need object references to call them. Also, remember that regardless of static or not static, if you're calling a method from the same class that that method is written in, you don't need an object reference or a class reference. So if I was in the actual math class, which you won't be because you don't have access directly to the math class, then you could just say square root. Okay, next is static variable, or next are static variables. So static variables or static fields, they're variables that do not have different values with every new object. So we've learned in Java object-oriented programming. We've learned how to write classes. We understand instance variables, right? So instance variables are variables that are tied to an object of a class. But sometimes classes will have other types of variables that are not tied to each object that is made from that class. So for example, if I had a dog class, and that dog class had an instance variable that was name, and then it also had another variable called count. And the count is a variable that keeps track of how many dog objects I've actually made. So this is going to change with every new object that gets made. But so for example, if I have made 3 dogs, then the count will be 3. And so if I tried to get the count for Spot, the Spot object, it would be 3. And if I tried to get that count for Rover, it would also be 3. And if I tried to get that count for Fido, it would also be 3. Because even though the static variable can change as more objects are created, it's always going to be the same for every single object in the class. And that's why it's called static, because it's the same for every object in the class, regardless of the object. Here's another example. So say we have a class called assignment, and the assignment class has a few different attributes. So we have a name and we have a point value. So for example, if I have some classwork assignment, then it's going to have a name, it's going to have a point value. But then there's also these other two these other two static variables. One of them is next classwork ID, and the other one is next homework ID. And so the way these would work is for every time I make a classwork assignment, I'm going to add 1 to the next classwork ID, so that the next time I make a classwork assignment, it would have an ID of 2 instead of 1. So that means every single new classwork assignment I make, it would be like classwork 1. Then the next one would be classwork 2. Then the next one would be classwork 3. Then classwork 4. And so this static variable is going to change as more objects are created. And so it's going to be something that once it's updated, then it's updated for the entire class. It's not just updated for the objects, the specific object of a class. Okay, so let's try a question with it. So consider the following class definition. We have a class called example. It has a private static field called goal, and it's originally set to 125. It also has a regular instance variable called current. And so we have a constructor, it initializes the current value, and then we also have a static method, public static void reset goal. And the reason why this is a static method is because it's using static fields. So if you're accessing static fields, then your method needs to also be static. So static methods access static fields. So if we do void reset goal, it's going to take a new goal and it's going to set the current static goal to whatever that goal is. So now if we write this code, we make a new example, we set our new example, we give it a current value of 150, then example 2, we construct another example and we set the value to 160. And then if we did example, which is the name of the class, we wouldn't use E1 or E2 here because remember that static methods are called with class names, not object names. So if we did example.resetGoal 145, what would be true about this statement? So objects E1 and E2 each have a variable goal and a variable current. Objects E1 and E2 share the variable goal and share the variable current. Objects E1 and E2 share the variable goal and each have a variable current. Objects E1 and E2 each have a variable goal and share the variable current. Or the code does not compile because static variables must be public. So what do you think? So this one is C. E1 and E2 will share the variable goal, so they'll both have, once the goal is reset, they'll both have the goal of 145. And they'll each have their own variable current because current is a standard instance variable, whereas goal is a static field. Alright, next one. So the next one says, consider the following class definitions. We have a gadget class. It has a static variable called status, and that's originally set to 0, but then in the constructor for gadget, status is set to 10. So every time a new object is made, status will be set to 10. We also have a static method called setStatus, which takes a new status and sets that status. The following code segment appears in a method in a class other than gadget. So we have gadget A equals new gadget, gadget.setStatus3, gadget B equals new gadget. Which of the following best describes the behavior of the code segment? So I'll let you read these over and think about your answer. And the answer to this one was the code segment creates two gadget objects, A and B. The class gadget's static variable, status, is set to 10, then to 3, and then back to 10. Because when gadget B gets created, the constructor gets called, and when the constructor gets called, status gets set back to 10, even though it was set to 3 in the line before it. Alright, so we're going to do more practice with these concepts in class tomorrow. We're going to discuss any questions that you have from the video. We're going to add some static fields of your choice to a given class, and then we're going to do an AP Classroom progress check. So any questions, make sure that you add them in your comment.